It's Mr. Cooper's YouTube channel. Today I'm going through a section of GCSE engineering NEA where we're looking at systems approach to engineering. This section's worth 10 marks and it's quite an easy 10 marks to get. So if you take your time and plan it out well, put as much detail in as you can, we can give you essentially 10 marks, which is a big chunk. When you consider the making is 15 marks, the research is 15 marks. It's quite a big chunk for probably an hour's worth of work. So for this, you're going to produce a block diagram to represent what happens in your system, your toy, your object, your engineered thing that you designed. This should show like it says here, a block diagram with explanations of systems operating within your product. Okay. And it doesn't matter what that product is, it's always going to have some kind of electrical, mechanical kind of system going on. The top mark box, if we look at that, is 9 to 10 marks. We're identifying and explaining in detail 2 or more of the systems and technologies used to engineer the product or organize and control the function of the product. So 2 or more systems. So chances are it's going to have some electronics, chances are it's going to have something that moves. So there's your 2 systems. We can look at and think about how they link. So literally, what does the person do? How does the person interact with it? What does the mechanism, what does the electronics physically do? Okay, and you're going to then show a detailed block diagram produced from multiple systems with subsystems, so bits that come off the side of it, and explain with feedback. Okay, so a bit of writing, bit of diagrammatic use, bit of electronic circuit flowchart off Circuit Wizard would do as well. Okay, so you can put that in. We're not going to watch a short video, we don't need that one. We're going to identify and explain the system that we're using. We're going to show it with block diagrams like it says. And this is a block diagram. So we always start on the left. You've got your start bit here, which is your input, this being a push switch, onto your microcontroller, which is your, from the majority of us, is our Genie 08 chip or Genie 18, depending on whichever one you've got. And then it goes onto your driver, which forces your LEDs or something to make your LEDs, to make your motor work, etc. So it's just a flow chart for this, and it talks us through it. You've got your output being LEDs on this one. It could be a motor, it could be a sound, a buzzer, or a piezo sounder. Okay, it depends which one you've chosen. But chances are you're going to have some kind of input, be that push switch, a sensor, a read switch, a tilt switch, whatever, some way of kind of activating your circuit. Then the kind of microcontroller, like I say, the brains of your circuit, and then your output. So we go input, control, output, and that's a circuit, or a system, should I say. So to do it on PowerPoint, really straightforward. We're going to start with this kind of lozenge shape with the rounded corners, and what happens, what physically does the person do? So for example, if I was going to make a cup of tea, I'd probably open the lid of the kettle, fill with water. I'd then go on to a decision. So this is where we're kind of coming up with something. So my cup of tea, I'm looking at the kettle. Is the kettle filled to a suitable level? If it is, I've got enough water in there to make a cup of tea, I can go yes and go downwards. If no, I'd go on to a subsystem or go back again, refill that kettle up to the specified limit. Okay, so yes and no. And that's good if we can get those subsystems going out the side, so I could check on how much water I've got. I could check on various different things. Next one would be switch the kettle on. Okay, so that's my process, this square box. Okay, so switch the kettle on. You could have a bit coming off the side there saying this is where the electronics switches in. So it allows the electronics to flow into the circuit, heating it up to a set temperature. When it gets to boiling, which is my decision again, is the water boiling? Yes, I can carry on. I can pour that water out. No, leave it to boil. Make sure the lid's closed, etc., because the kettle won't boil if the lid's up. And you can see I'm kind of gradually building that up. You could then talk about onto the subsystems, which gives us more marks. Going sideways, I could be saying, apply the water to a certain level. Is there enough water in the cup? Yes, no. If yes, take the tea bag out. Is it to the desired strength? Yes, no. Apply milk. Is it to the desired colour? Yes, no. Apply sugar. Have we got the right amount of sugar? You can see where we're going with that. Stir it around for a set period of time. etc., etc. And then we finish, we go to an end, because with a cup of tea there is going to be an end. Maybe on your toy there won't be an end. It depends what you're doing, or your object depends what you're doing. Last year or the year before was a sports training aid, which was to help people practice some kind of sport. So that could be on a kind of constant loop depending on what you were doing. Okay, so let's have a look. Here's an example. So you can see we're talking about an input, a process, and an output. And we've got down here process magnets to go together, and the alarm and LED goes off. So if the input and the magnets go together, the alarm goes off straight away. There's nothing in there. It's like an alarm system. It's talking about the shed door being opened, which is the input. The magnets become detached, so opens it, starts that circuit. Circuit's broken, therefore the power supply allows a current to flow through the circuit. This then leads to the outputs. There's what happens in the middle, and then the output. What is the physical kind of sign of this alarm going off? Red LED comes on as well as the alarm will be activated. There will be a sound and then a light output. This will be indicated the shed door has been opened. The magnets have been disconnected. So we're explaining physically what happens as well as diagrammatically. Okay, and on the right hand side we've got our flow chart on here. Alongside this, if you could do your circuit wizard circuit flow chart that you've got, that's quite a wordy sentence to say, put that in there. That would give you your 10 marks. So we've got the detailed kind of block diagram here. You've got your bit of writing, which I'd like a little bit more than I'm showing you here, but not too much. It's not massive. And then your electronic circuit that you've got next to it, which shows the programming, the circuit wizard programming of the Genio 8 chip that you've done in there. Okay, and that would be your 10 marks, probably for about an hour's worth of work. Another way you could do it is like literally a systems diagram or a block diagram like that one. Okay, I'm not going to go too much onto that because I personally like the flowchart diagram. And there's your electronics, where we've talked about the outputs, how long it stays on for, when it goes to 0 and 1, etc., etc. And you've got your the daytime lights here, and then a bit of a subsystem telling us what goes on with the daytime lights up here as well. Okay, that's how to get to the top marks. We've got more than one system or subsystem routine going. Okay, so if you look at that, add in that bit that you've already done to something like that one there, where you've got your PowerPoint flowchart, might be drawn on tables, etc., to put in, and then just a bit of writing explaining, right, what happens when buttons pressed, what physically happens to this object I've designed. How does it work? How does the person interact with it? Okay, that's quite an easy 10 marks, and probably one slide, maybe pushing on to 2, but I'd essentially look at one slide. Okay, we don't need to extend this over a lot of pages just to make it look better. Leave it on one with circuit diagram, systems designing, however you want to title it, but make sure it has got that title on. Okay, that's straightforward enough. I'll leave it there. Have a look at my other videos for the evaluation sections, and good luck.